Welcome to a new episode of the Efficiency and Reliability Podcast. This is John, your host, and today we'll discuss a significant success story from a biomass power plant in northern Italy. The plant, which converts wine residue and other organic materials into electricity, faced a serious challenge due to severe boiler corrosion. The plant's boiler, a 13.7 megawatt air-cooled system with a moving grate, generates 50 tons per hour superheated steam at 50 bar and 480 degrees Celsius. The corrosion caused frequent detachment of refractory tiles, rapid wear on exposed boiler tubes, rising maintenance costs, and unplanned downtime. Over 2 years, plant availability dropped by 15%, and unplanned shutdowns increased from 2 to 7 annually. To address these issues, Integrated Global Services partnered with Corf Engineering to provide a comprehensive solution. The approach included removing a 2-meter refractory band at the top of the boiler's first pass, installing corrosion-resistant hangers, applying high-velocity thermal spray cladding at a thickness of 0.5 millimeter, and incorporating specially designed refractory tiles from Corf. This innovative solution, described as a game changer by Corf's director Federico Colombo, integrated seamlessly into the existing boiler structure without requiring modifications. The project was completed during a scheduled 3-week maintenance shutdown. The first week focused on removing the old refractory and preparing surfaces for new hanger installations. In the second week, HVTS cladding was applied, followed by rigorous quality control checks. The final week involved installing the new refractory tiles and gradually restarting the system. 4 years later, the results have been impressive. The plant reported no detachment of refractory tiles or corrosion on the protected boiler tubes, achieving a 22% reduction in maintenance costs and a significant drop in unplanned shutdowns from 7 to 1 annually, unrelated to the protected area. Overall plant availability improved by 12% compared to pre-installation levels. The HVTS cladding demonstrated outstanding durability with minimal thickness reduction of less than 0.02 millimeters after 35,040 hours of operation under high-temperature flue gases and corrosive ash deposits. Areas previously experiencing corrosion rates of up to 2 millimeters per year now show rates below detectable limits, reflecting superior performance and structural integrity. The plant is planning to expand the protected area in 2025. The success of this project illustrates the potential of HVTS cladding technology for widespread use in mitigating corrosion in power generation facilities. By combining advanced refractory designs with HVTS applications, plants can shift from reactive maintenance to proactive corrosion prevention, extending equipment lifespans and improving operational efficiency across industries. Thanks for listening. And if you're interested in learning more about high-velocity thermal spray, visit our website at www.integratedglobal.com. We'll see you on the next episode.